Hello all. In the series of covering SAT topics, this is our 14th video where we will learn about basic geometry facts. So starting with angles and lines. So let's see what are angles and lines. Basically here we will talk about angles formed by at least a pair of lines. So we'll start with linear pair. So this, sorry, suppose we have a line which is given like this, and this line is divided into two parts by another line. So it's like this. Then you can see there are two angles formed. So using these two angles, one is this, suppose x, and this y. So sum of these two angles, x plus y, is equal to 180 degree, and they are called as linear pair angles. That means when two lines intersect, then the adjacent angles formed are linear pair angles. Even if multiple lines will be there in a straight line, if it is divided into multiple parts, then all have a sum of 180 degree. So we can simply say angles in a line sums to 180 degree. So this is linear pair angle. Now moving to next, that is vertical angles. So in vertical angles, if two lines are there such that they are just intersecting each other like these two lines, then the opposite angles like this and this, or we can say this or this, these lines are called as vertical angles, and these are congruent. So we can say x is congruent to y and m is congruent to n, and these angles are called as vertical angles. Now we'll see about angles formed in a pair of lines that are parallel and a transversal drawn on it. So suppose this is a line, first line, then this is the second line, both are parallel to each other, and we are having a third line which is intersecting both of them. So these are parallel lines, and these parallel lines are cut by a transversal. So you can see 1, 2, 3, 4. Similarly 5, 6, 7, 8. Total of 8 angles are formed. So all the angles are having some specific name which we will learn here. We will start with first, that is linear pair angles. So as you can see, how many linear pairs are there? Will not count exact, but see, I'm just giving an example. Angle 1 and angle 2, angle 2 and angle 3. Similarly angle 3 and 4, 4 and 1. 4 pairs are in here, first intersection point, and 4 pairs will be in the second intersection point as well. So we can say angle 5 and angle 8, angle 6 and angle 7, angle 5 and angle 6. These are linear pair angles, and as we have already discussed, the property of them is the sum of these angles are 180 degree. Then second, vertical angles, that also we have already discussed, but if we will see which angles formed here are vertical angles, then first and third. So angle 1 and angle 3. Similarly angle 2 and angle 4, angle 6 and angle 8, and angle 5 and angle 7. These are the 4 pairs of vertical angles. Moving on to next, that will be corresponding angles. Now from here on we will also see the properties. So corresponding angles. So here two angles either up on the same side of the transversal, either above the parallel line or below the parallel line, are called as corresponding angles. For example, angle 2 and angle 6, angle 1 and angle 5, angle 3 and angle 7, and angle 4 and angle 8. These are the pairs of corresponding angles. And if we talk about the property of corresponding angle, then they are congruent. Moving on to next, we have to learn about alternate interior angles. Alternate interior angles, as it is clear from the name, it will be inside the two parallel lines and they will be on alternate sides. So angle 3 and angle 5, angle 4 and angle 6, only two pairs are there. Angle 3 and angle 5, angle 4 and angle 6. If we talk about the property, then they are also congruent. Next, same side interior angle. If we talk about same side interior angles, then we will be getting, as you can see, same side interior angles 3, 6 and 4, 5. So angle 3 and angle 6, angle 4 and angle 5. If we talk about the property of this, then they are supplementary. That means sum of them will be 180-degree, like linear pair. Now, similar to same side interior angles and alternate interior angles, we will be having same side exterior angles like angle 1 and angle 8, angle 2 and angle 7, and the sum of them will be 180-degree, just like same side interior angles. And similar to alternate interior angles, we'll be having alternate exterior angles like angle 2 and angle 8, angle 1 and angle 7, and they have also the same property as alternate interior angles. That means they are congruent. So I'm not writing those things. Now next we are having we have to learn about triangles and polygons. In triangles and polygons, what we will be learning first, as we already know that sum of all angles in a triangle is 180-degree. So I'm not going to discuss that thing. Here we will start with exterior angle of a triangle. So let's draw a triangle. Suppose this is a triangle where one of the side is suppose extended like this. So you can see one angle is formed here. So let's say this angle 1 and 2, 3 and angle 4. So here what we have to know is, see, as we already know, angle 1 plus angle 2 plus angle 3 is equal to 180-degree. We already know that angle 3 and angle 4 are linear pair. So those angles will also be 180-degree. So from these two equations, we can say angle 1 plus angle 2 plus angle 3 is equal to angle 3 plus angle 4. Angle 3 from both the sides are cancelled out, and we are getting angle 1 plus angle 2 is equal to angle 4. That is the property of exterior angle of a triangle. That means we can say an exterior angle of a triangle is equal to sum of its non-adjacent interior angles. Angle 3 is the adjacent one, but non-adjacent interior angles are angle 1 and 2. So that's why we will say like this. Now moving on to next topic, that is polygons. So polygons is related to just triangle only. So if we have a square, suppose this is a square. In this square, you can see using one vertex at a time, we will use only one vertex. Then how many triangles we can generate? So you can see only two. We'll choose only one vertex, and from there we will join the diagonals and see how many diagonals we can make. So we can say number of diagonal using only one vertex and sum of angles. Here we will be writing. So as you can see, number of diagonals using only one vertex, that is 1. How many triangles are formed? 2. So 180 times of 2, that will be 360-degree. That we already know that sum of angles of a quadrilateral is 360-degree. Now let's move on to pentagon. Suppose this is a pentagon. Again, we will be using only one vertex. We can use any of the vertex. Suppose we are using this, then how many diagonals we can draw? 1, 2. Only 2 diagonals we are able to draw. And since we are able to draw only 2 diagonals, so you can see there are 3 triangles. So 180 times of 3, that is 540-degree. Similarly, we will move to next, that is hexagon. In a hexagon, you can see if we use this diagonal, then 1, 2, 3 diagonals are there, and so 4 triangles are there we are having. So as you can see, we are always having one more triangle than the number of diagonals. So here 4 times 180-degree, so that is equal to 4 times 180-degree, that is 720-degree. So on continuing this pattern, what we'll know from here is, see, sum of interior angles of n-sided polygon is equal to, you can see it's it was 5, so we got 3 triangles, so 3 times 180. In 4, 2 triangles, so 2 times 180. In 6, we are getting 4 triangles, so 4 times 180. So we'll always get 2 less triangles, so we can say n minus 2 times of 180-degree. So that is the sum of interior angles of a n-sided polygon. Then moving on to next, suppose this polygon would have been a regular polygon. So what is regular polygon? A regular polygon will be having all the angles and sides congruent to each other. So we can say here each interior angle of a n-sided polygon, that we can say from here, that will be n minus 2 times 180-degree, that is sum of all the angles divided by number of sides, because all angles are equal. If we talk about exterior angle, then we have to remember that sum of exterior angle of any polygon, sum of exterior angles of a polygon, that is always 360 degree. It doesn't matter how many sides are there. Now if it is a regular polygon, then for finding each exterior angle we'll simply divide by number of sides. So that is about triangles and polygons.